Well, welcome to this Bon Salon video. It's a great pleasure to have Coralie Gomez here with me today. She's written an excellent book, Math on Trial. It's an American publisher, that's why it's not Maths on Trial. Coralie, welcome. Can you just tell us a little bit about your background?
I studied maths at Cambridge. So I grew up in France and then I left to go to Cambridge. And my mother's also a mathematician. I wrote this book with her.
Okay.
And when I finished Cambridge, I wasn't actually really sure what to do because I didn't just want to go work in the city. And my mum was just like, well, everyone should write a book. So, let's write a book together. We'd actually already, a lot of these cases that are in the book, discussed in the book, are quite famous and we knew about them. And as mathematicians also, you hear about a lot of them. We did a little bit more research and we realized that there was actually a lot of examples of maths being misused in criminal trials. And
well, that's particularly interesting to our clients who are expert witnesses. And what about Bayes, the Bayes? Explain about
so Bayes is a special area of maths, a special area of probability, and it's very, very useful actually for stuff like dealing with evidence, because what it does exactly is assess the new probability of guilt given some new evidence.
Okay.
So you can basically, recalculate the probability of guilt every time you get new evidence using the Bayes theorem. And it's used a lot in cases of DNA because DNA analysis comes with a probability measure anyway. And you can then try to measure the importance of all the other evidence compared to the DNA evidence. And Bayes is really the best way of doing that, but there's been lots of problems because, juries find it very difficult to understand.
So there's complexity for the jurors.
Exactly.
Now, I think you've analysed 10 cases in the book.
Mm-hmm.
I think particularly of interest to perhaps some of our viewers would be the Sally Clark case, which of course is an English case.
Yes. And
can you just tell us the essence of that? What's the maths in that?
So this one actually is a very, very simple mathematical concept, which is that if you have two independent events, you can just multiply their individual probabilities together to get the probability of both of them happening. This is completely wrong if the events are not independent. And in real life, it's actually quite difficult to know if events are independent. It's not like, when you have a math problem and you throw a dice twice and, the two throws are independent from each other. In real life, it's a bit more complex than that. I mean, a lot more complex than that.
Sure.
What happened in the Sally Clark case is that her two of her three babies died of cot death. And the expert witness in the case was Sir Roy Meadow,
Sure.
who was an expert witness at countless cases of cot death, in fact.
Mm.
And what he did was to calculate the probability of these two cot deaths happening. So what he did was he used well-known figures about the probability of one cot death in a family of the same social background as Sally Clark's, which is quite a low probability because she, both parents had jobs.
She was a solicitor, I think.
She was a solicitor, no one smoked or did drugs. So in a family like that, the probability of one cot death is quite low. It's about 1 in 8,000. But then he just squared that probability to get the probability of two cot deaths. And obviously he got a tiny, tiny number, which he said, this is so tiny that it cannot have happened by chance.
So he didn't understand the maths?
No, he didn't. I mean, he didn't understand. It's not only the maths, it's also even medically, he didn't really understand what independent means. So
Sure.
The thing with cot death is that it's not, a condition. Cot death is not an illness.
No.
It actually englobes loads of potential illness. It's just that babies are, so small and we don't really know that much about them. And so there's lots of different possible causes of death. But, it's not that easy to determine. And so cot death englobes lots of possible deaths, including, most probably, genetic causes of death. So that's absolutely not independent, obviously, because they would have come from the same parents. So if there's somewhere genetic thing, it's very probable that they would both have it. Cot deaths are definitely not independent.
So what's the lesson for Sir Roy?
the lesson for Sir Roy is to not deal in things that he doesn't understand.
So he went outside his field of
He
expertise,
did.
basically.
Definitely.
So, for our experts, if they come across something like this, what should they do? Should they?
You should go to someone who's an expert in probability.
Okay.
So what he was an expert in was mistreatment of children, and he did,
Pediatrics.
yeah, and he also did a lot of dealing with mothers and their psychological issues, the ones who mistreat
So
their
there's
children.
nothing he knew about.
But no, yeah,
Okay.
no math at all.
No maths.
So no.
I think another one of the cases was Amanda Knox, which of course is still in the
Yes.
news.
Yeah,
I
actually
wasn't
the
really
trans-
aware there was a maths element there. What's the?
So it's not a pure math thing. It's more of a just understanding, how you should look at things, basically. But math can help with that. So what happened in the Amanda Knox case is that they found a knife in Raffaele Sollecito's house. So Meredith had never been there. And they noticed that the knife looked like it had been scrubbed quite recently. So they, took it to examine it. And they found a tiny, tiny amount of DNA on the blade. I mean, it was really tiny. It was actually too small for what is normally accepted in court. And it was too small for the normal settings of the machine, but the genetic analysis, the DNA analysis, she, pushed the machine a bit further than normal. And she did manage to get a very clear DNA profile of Meredith. The profile was very clear. It was just because the sample was so small, the DNA profile looks like a graph with peaks. And the peaks were very low. They were lower than what is normally accepted. But it was still very, very clear. It's pretty obvious that it's Meredith. So, as you know, in the first trial, they were convicted, but then they appealed.
On the appeal, yeah.
Yeah. And so the appeal judge said he just threw out that evidence completely. He said, it shouldn't have been accepted in the first place. And what had happened in the meantime, I mean, this was like 7 years later, so the analysis was much better, and the doctor said, well, I can just analyze it again. And the judge just said, no, that wouldn't be any use because, it's too small anyway. So,
Okay.
If you analyze it again, well, it still won't be a result that I can accept. It won't bring anything more, which is actually a wrong conclusion. Even if you have a test that's quite uncertain, if you do it twice and get the same results again, then you can be a lot more certain of your answer. So
was this perhaps some fault on the judge's part? I don't understand.
Absolutely.
Yeah.
Yes.
Yeah. And I think one of the other cases you mentioned was Hetty Green.
Mm-hmm.
That's quite.
That's quite an interesting one. You're probably the first person who asked me about that one particularly. It's really interesting. So this was in the early 1900s, and Hetty Green was from a very wealthy family, and she was herself very, very interested in money. I mean, it was a bit of an obsession of hers. She, dealt in stocks and bonds herself, and she made lots of money. But when she was quite young, before she had started really with that, her aunt died. Well, first her dad died, and he left her his money, but in a trust that was managed by other people, which made her very, very angry. And then she knew that her aunt was about to die, and she didn't want the same thing to happen again. She wanted to make sure that she would get the money straight out, that she would be able to do what she wanted with
trust.
it. And what she wanted to do with it was just to make more money. She didn't want to go around spending it on whatever. She just knew that she was the best person to do that. So unfortunately, she was a very unpleasant person.
Oh, no.
And so she went over to see her aunt and managed to antagonize everyone. And especially, her aunt was very, very ill at the end of her life. And she got this doctor who was, giving her drugs, basically opium, and just sort of being her friend. And I mean, this was all boding very badly for Hetty. And then Hetty got in such an argument with everyone that she was then not allowed to go visit her aunt anymore. So the only thing she could do was wait for her aunt to die. And when that happened, a will came out. So Hetty had previously forced her aunt to write a will giving her all of the money and no trust or anything. But then when she died, apparently her aunt had written a new will. And This will obviously gave lots of money to the doctor, and didn't give Hetty any money outright. It just left it all in a trust for her.
Exactly what she didn't want.
Yeah, exactly what she didn't want. So what she did was she took the case to court, and she produced a document which no one had seen, which she said she had written with her aunt when at the same time as they had done the previous will, so her aunt was too ill to write, so she had dictated it to Hetty. It was all written in Hetty's hand, the same as the will, and then it was signed by her aunt Sylvia. And this document said, I know that I'm very ill and people are going to try to take advantage of that, so I just want to make sure that no will that is written after this one will count, which would have been very good for Hetty. And so she said, here you go, the new will isn't valid. And what obviously the other side tried to do was to prove that it was a forgery and that the signature at the bottom of this document was a forgery.
Yeah.
So the way they did that is actually very interesting. And first of all, it's quite interesting because all the expert witnesses on both sides were incredibly important people at the time. So, you know, the best mathematicians, the best biologists, the best everything. And the way they tried to prove that the signature was a forgery was that they compared it to the signature on the will. And they said, okay, they're basically identical. It looks like it's been traced, basically. It's the same one exactly. And so they tried to calculate the probability that two signatures would be identical. And they came up with a model for it. They used a binomial model. I mean, he compared lots of different signatures of Sylvia's. Old ones, new ones, everything. And then he came up with a binomial model, which he thought modelized the probability of two signatures having a certain number of lines in common. And these had all their lines in common. So according to his model, the probability of that happening was tiny. I mean, you know, 1 in many, many, many million.
Right. So
he said, it's just not possible that, you know, she just made two signatures and they just happened to be the same. Hetty lost her case. And it is generally thought nowadays even that she had forged that document. But, I mean, the mathematical model used by the prosecution was actually quite wrong. Even if you look at, because they had collected all this data on all these signatures that they examined. And if you look at the actual data compared to the data predicted by the model, it doesn't really match up. There are many less signatures that aren't similar than predicted by the model, and there are many more that are similar. And also, you should take in fact things like, you know, when the signatures were made and what pen she was using and, you know, what position she was sitting in and everything. Yeah. So it is actually a lot more possible than you would think that two signatures she made exactly one after the other, you know, would be very similar.
Pretty similar.
Yeah.
And so that's interesting. I think you've been in depth to 7 other cases. So I just want to see if we can summarize some of the key lessons for experts. What would you like to tell
I guess, so first of all, most important is to make sure that your expert is an expert in the correct field.
So stay within your qualifications and experience what you know about.
Exactly. I mean, this happened in another very high-profile case, the Lucia de Berg case. And, you know, the expert in that case just wasn't an expert at all. He didn't really know what he was talking about.
Well, we've seen this in several cases.
Yeah.
And any other lessons?
Other lessons is, well, it's very important that when you are using maths, because maths is actually an incredibly useful tool, and I think it really should, you know, have a big place at trials where it is useful. But the problem is that there's, you know, it doesn't really translate very well from when the expert is saying it to then what the jury understands or what the judge.
So it's communication of complex issues in a layman's language.
Yeah. So exactly. So you need to make sure that you're not doing things that are too complicated for the jury. But you also need to make sure that the jury has the tools to understand what's happening.
So would you advise use of visual aids or demonstration aids? Or?
Anything that would help. For example, for the Bayes theorem, which is actually being used quite a lot. Well, they are trying to use it quite a lot, but it normally gets thrown out of court because it's considered to be too complicated or.
So whose fault's that?
Yeah.
Bayes institution.
So no, it's I'm not sure whose fault. I mean, obviously there have been cases where the expert witnesses have just explained it in a completely the wrong way, but there are also cases of judges just, there's also a very common argument, which is that maths goes, it's not how we want to conduct our trials. We want to conduct our trials in a human way, intuitively, and like with human empathy, and maths goes against that. But I just feel that if your intuition is wrong and the maths is right, obviously we should be using the maths, yeah. And intuition is often wrong,
Absolutely.
So, yeah.
So there's something about communication,
realizing
who the audience is, and also the importance of maths.
Exactly.
Not just basing it on gut feeling or intuition.
No.
Anything else?
Well, the best thing would be to just have some guidelines about when you're allowed to use the maths, what you're allowed to say exactly, and guidelines basically would be good.
Okay. Listen, Coralie, I'm very grateful to you. Thank you very much.
Thanks for having me.
As I said, here's the wonderful book that she's written. I do recommend you read it. It's very interesting, and these cases are analysed in some depth. So thank you very much indeed.